What are the methods we have discussed in class 11 in order to prepare aldehyde and ketone? One was from alkene. So alkene केमती बनेगा? By reductive ozonolysis. So reagents are O3, zinc water or zinc acetic acid. मन पड़छि? So zinc water or zinc acetic acid. So this reagent, suppose we are taking this alkene in the presence of O3. The double bond अछि, double bond completely break hobo and double bond completely break hobo, then it makes ozonide. First step, it makes ozonide. Okay, so then the ozonide बनिबो से reduce होबो by the reducing agent. कौन अछि reducing agent? Zinc water. So that will make aldehyde or ketone. So a method re we can prepare both aldehyde and ketone. Okay, student, you can see. Now can you write one more question? Write on the product. Then quickly write down the product. I hope all of you are writing. जेतटा भी double bond थिबो, so at all the double bond side it will make ozonide. जेते double bond अछि सब जगह ozonide बनिबो आ ozonide बनि सारला परे तापर ozonide reduction होबो, reduction हेले it will make the mixture of aldehyde or ketone depending upon the nature of the alkene. So I hope all of you are writing. Okay, चलो देखो CH5 okay, so then ozonide dissociate केमते होबो? So how many products will be formed finally? First देख परिबो हम तक जे numbering करिबो, this is product 1 and product 2. So first product is CHO, CH, CTH5, CHO. Second product CHO bond CHO. Note down. Middle student, this is first method by which we can prepare both aldehyde and ketone. Okay, हमें एठी preparation रे देखिबा किछि मेथड अछि those are used to prepare both aldehyde and ketone. Then some methods are there, those are used for the preparation of aldehydes exclusively, then ketones exclusively. So this method clear. So second is hydrolysis of alkyne. So first देखिए which are the reagents used for hydrolysis of alkyne. Now that is dilute H2SO4 in the presence of HgSO4. Dilute H2SO4 in the presence of HgSO4. So एटा हला तमर कोन ना हाइड्रेटिंग एजेंट. सपोज हमें कीटोन नेले dilute H2SO4 in the presence of HgSO4, then normal Markovnikov rule use करके कौन हबो हाइड्रेशन हबो. So after hydration the product कौन बनला इनल बनला. yes or no इनल. तो normal hydration means एटा कौन ना this follows the Markovnikov rule. So Markovnikov rule जो follow कला परे इनल बनिबो. So इनल once formed हम जानचे इनल and ketone both are tautomers. So keto इनल भितर जो tautomerism बनुची तातिर more stable किए keto form ना इनल form ना. in general keto form is more stable. Inal form stable हबो दीटा mainly दीटा condition, that is one is the inal form कौन stabilization पे first हला if it is aromatic in nature, और second हला if it is stabilized by intramolecular hydrogen bonding. Which part छ intramolecular hydrogen bonding. ताले जो inal बनिबो ये tautomerize हेजिबो to form ketone हला to form ketone. Now the question is हमें टिके पूरा डिस्कस कर ले. These methods are used for the preparation of both aldehyde and ketone. हमके देखले ketone बनुची. So can we make aldehyde also? हमें aldehyde भी बनी परिवा from acetylene only. Dilute H2SO4 in the presence of. So write down write down the reaction. So first it makes enol. So enol जो बनिबो से tautomerize की ketone रे convert हो. Write down. तो बुझा पड़ला. हमें देखियो only ethyne forms aldehyde. Enol एठी aldehyde बनला. Only ethyne forms aldehyde and all other alkynes will make ketone as the product. तापर next कौन. So ये ला preparation of aldehyde और ketone. तापर next method है ला हमें तुम already पढ़िছো सेटा in alcohol chapter. From alcohol so how to prepare aldehyde and ketone from alcohol. Now by using mild oxidizing agents. So mild oxidizing agent किए क्या आछंती ना मैं नहीं परिवा PCC CrO3 in pyridine or PDC. PCC pyridinium chlorochromate, PDC pyridinium dichromate. Okay. So इतरे कौन होबो ना primary alcohol is converted to aldehyde and secondary alcohol is converted to ketone. ताको एक्सप्लेन करा दरकार अछि स्टूडेंट देखि दियो जदि हम एठी नबा PCC CHO जदि हम सेकेंडरी अल्कोहल नेले CrO3 in pyridine, so that forms ketone. बुझा पड़ला अच्छा आउ कोन नहीं परिबा ना metal as oxidizing agent. So which metal? We can take metal copper or silver at about 300 degree centigrade. Copper or silver at about 300 degree centigrade. Okay. तली कौन करियो सेम प्राइमरी alcohol to aldehyde and secondary alcohol to ketone. Note down. Quickly note down, students. Okay. तापर हम नेक्स्ट कौन देखिबा तो गोटेटा कन्वर्जन लिखिलो right these two conversions okay alkane to ketone then alkyne to also ketone any doubt student quick complete so how many have completed raise your hand okay see in this first हम जानछे alkane रू हमें directly halo alkane ही बने परिबा again here different type of carbon atoms are involved so we have to follow only bromination that identical carbon thanta then we can follow either chlorination or bromination but here different carbon So we have to get the major product as 2-bromo, so bromination. Then you can here use aqueous KOH, nucleophilic substitution reaction, OH. Then you can use PCC. This is first. Second is the reactant contains 3 carbon atoms and the product 4 carbon atoms. So that means it is ascending series. 1 carbon atom is increased. So how to increase the carbon atom? And again it is the terminal alkyne. So terminal alkyne re carbon atom increase kariya pai which method we have to follow? Man pakao. It contains acidic hydrogen. So we can take any active metal so that it will form alkylide. Alkylide बनला पर then हमें nucleophilic substitution करी परिबा. So we have to use only 1 carbon. We have to increase only 1 carbon. Okay. So this is alkyne. तापर हमें use करो dilute H2SO4 in the presence of HgSO4. So that forms enol. Which further tautomerase. Student, please all of you mute yourself. Okay. So these are the 2 conversions. Now we'll continue the preparation of aldehyde and ketone. Next is preparation of aldehyde only. Preparation of only aldehyde. So first, under the preparation of only aldehyde, that is Rosenmund reduction. Rosenmund's reduction. So in Rosenmund reduction, which are the reagents or which are the reactant we have to take? We have to take acid halide. Okay. So acid halide, H2, then palladium in the presence of barium sulfate. So acid halide will be reduced to give aldehyde. So here we can prepare both aliphatic and aromatic aldehyde. We can prepare both aliphatic and aromatic aldehyde. Okay, quickly note down. Second method we'll discuss. Stephen's reduction. So here the reactant is nitrile. Okay, reactant is nitrile. We have to take HCl, SnCl2, that will be reduced to give imine. So imine is hydrolyzed to give aldehyde. Imine is hydrolyzed to give aldehyde. Can you write the mechanism, students? What is the mechanism for this particular reaction? Can you try? First, Sn is present in the +2 oxidation state. So SN2 plus is converted to SN4 plus 2 electron. The 2 electron release away, those will react with 2H plus 2 electron. H plus quote from the acid HCl. So that will give 2 hydrogen. So these are nascent hydrogen. Nascent means newly born. जोटा कहती आज जब हम देखिए hydrogen generally exist in 3 forms. One is molecular form, then atomic form, then nascent hydrogen. So तार जो देखिए सबुठारे stable है molecular form H2, then atomic form, and nascent hydrogen is more reactive. ताले once the nascent hydrogen is formed, then that attacks across the pi bond. So it is reducing the nitrile into imine. तापर hydrolysis होगा. Now the question is why SN is oxidized, SN2 plus is oxidized to give SN4 plus. What about the inert pair effect? जब हम देखिए inert pair effect इटी कहीं की dominate हबनी हम जानचे oxidation number or stability depends on few factors like electronic configuration, inert pair effect. So out major factor अछि hydration and lattice enthalpy, and lattice enthalpy. So SN4 plus is more stable than SN2 plus due to its high hydration and lattice enthalpy. So SN2 plus is stannous is oxidized to give stannic ion. So this is the mechanism, Stefan's reduction. So I hope all of you written. তারপরে next দিব using dipole H. Using dipole H. So what is the full form of dipole H? That is diisobutyl aluminum hydride. Diisobutyl aluminum hydride. Okay. So aluminum hydride diisobutyl aluminum hydride. It is one of the reducing agent. So it reduces particularly ester and nitrile. It reduces particularly ester and nitrile, and it doesn't affect nitrile into aldehyde. Okay, it reduces ester and nitrile into aldehyde. It doesn't affect olefin bond. It doesn't affect olefin bond. Okay, so I'm the suppose we are taking CTH5 aldehyde, then write down okay. So it doesn't affect the olefin bond. Friend, 2 minutes, quickly note down. Student completed? Up to this, any difficulty? If any difficulty, write in the chat box. No, okay, good. So next is, so this is all about the mainly aliphatic aldehyde. Okay. Then preparation of aromatic aldehyde. Okay, preparation of aromatic aldehyde. Now, how to prepare aromatic aldehyde? Student, how to prepare aromatic aldehyde? First, from alkyl benzene. Around toluene deva. Okay, we can take toluene, alkyl benzene, or toluene. So from alkyl benzene, one is by using chromyl chloride. Yes, chromyl chloride. So what is the formula of chromyl chloride? CrO2 Cl2. So when alkyl benzene or toluene is treated with chromyl chloride, so it will make the intermediate chromium complex. So it undergoes hydrolysis to form aldehyde or benzaldehyde. So this intermediate is known as chromium complex. Chromium complex. Quickly note down, student. Written, student. So ଆମେ ଏଠି ଦେଖିବା from alkyl benzene or toluene there are three methods in order to prepare aldehyde. So next is side chain halogenation followed by hydrolysis. Write down side chain halogenation followed by hydrolysis. Suppose we are taking toluene, and if it undergoes halogenation. Halogenation means आमे reagent कौन नबा ना suppose आमे नेले Cl2 एटे मु 2 molecules को replace करियार अछि 2 hydrogen to replace करियार अछि then we have to take 2 equivalents of halogen. Okay, CHCl2, then it undergoes 2 chlorine will be replaced by 2 OH, and it will remove 1 water molecule, because we know if one carbon has 2 OH group, okay, one carbon has 2 OH group, then it will release 1 water molecule immediately. So this is next step. लिख दिया. Quick. Okay, friend. Next, by using chromic anhydride, if we are taking, okay, if you are taking toluene and CrO3 acetic anhydride, so 2 hydrogen atoms will be replaced to form diacetate ion. जो diacetate ion बनेला, after this hydration that will form benzaldehyde. After hydration that will form benzaldehyde. Note down. So last method of the preparation of benzaldehyde. So fourth method कहिबा. So आपको हमें ABC इसमें use कले, all are from alkyl benzene. So it is Gattermann-Koch reaction. Next is Gattermann-Koch reaction. Okay. So Gattermann-Koch, here we have to take benzene, CO, HCl, LCl3, that forms benzaldehyde. Can you write the mechanism, student? Just take 1 minute, try the mechanism. Quick, try the mechanism. Are you writing? Okay, so actually this one follows the mechanism EAS, electrophilic aromatic substitution. Which is the electrophile here? ଆମେ କ'ଣ ନେଇଛେ ଏଠି AlCl3 means anhydrous aluminum chloride. So anhydrous aluminum chloride and HCl. So aluminum chloride is Lewis acid. So it will take the chloride ion and releases H plus. जो H plus release होगा. This is the structure of CO. H plus. So where it is going to attack? Oxygen contains lone pair and carbon as well. So here the lone pair availability is easy. Carbon. Why? Because carbon is less electronegative. So after attacking this, it forms. Okay. So CHO formula that is acting as the electrophile. So it attacks benzene ring. Suppose it is attacking this. Then plus one hydrogen here. So minus H plus. The product is CHO. So write down the mechanism, student, quickly. So with this, the preparation of both aliphatic and aromatic aldehydes are over. So I hope no problem. If any problem, write in the chat box. Okay. So next is preparation of aromatic ketone. Or first aliphatic ketone, then aromatic ketone. Preparation of ketone. Okay. First, by using, हम तो ऑलरेडी देखिथिले स्टार्टिंग रो अल्किन अल्काइन एंड अल्कोहल रो सेथरे में कीटोन बनोचे बट एबे जो मेथड हम देखिबा सो दोज आर एक्सक्लूसिवली फॉर द प्रिपरेशन ऑफ कीटोन. ओके एथरे में एल्डिहाइड बनेबानी बाय यूजिंग CdCl2. So if we are taking Grignard reagent, so first it forms R2CD plus MgCl2. First step clear? So the balance करियर चाहिए, then you can put 2 here and here also 2. So now it is balanced. So next कौन 2CD plus RCOCl. So that forms RCO और R dash नहीं जाओ R dash plus CdCl2. CdCl2. So this is how we can prepare ketone. This is how we can prepare ketone. Write down at the place of suppose R we are taking CS3 magnesium chloride plus CdCl2. So that gives whole twice CD plus MgCl2 then चाहिए balance करी परिबा. Then plus एठी हमें जदि हमें unsymmetrical ketone बनेउ चाहूचे then we can take different alkyl group, so that will give CdCl2. So quickly note down. Make it fast. And now next from nitrile. From nitrile. Okay. So I'm in the Grignard reagent. So in this case, कौन होगा? Address. It is R here. Okay. So it is attacking to this. So एठी में hydrolysis करिवा. So that makes write down. Over. Then the next method, the preparation of aromatic ketone. Already a method them पढ़ी preparation of aromatic ketone. Which method? That is Friedel-Crafts acylation. Friedel-Crafts acylation. Okay. So first of all, we have to take benzene, then CS3COCl in the presence of Lewis acid catalyst. So this is acetophenol, aromatic ketone. Then benzophenone बनेगा चाहिए ताले कौन करिवा? So it forms benzophenol. It forms benzophenol. Friend, write down. Any difficulty up to this? Any difficulty, student? Okay. তাহলে ঠিক আছে। So we'll take preparation salla. We'll take a short break. Tama 10-15 minutes ro. Then in next session we'll start the properties of aldehyde and ketone. Okay. So you can log in. So after the break, immediately we'll join. Okay. Thank you. Welcome back, students. So in the first session, we have discussed the methods to prepare aldehyde and ketone. Okay. So we'll discuss one more method, that is that is to prepare carbonyl compounds. So it is heating calcium salt of carboxylic acid. Okay. So calcium salt of carboxylic acid so when it is heated, it releases okay, you can see calcium carbonate and one ketone. Calcium carbonate and one ketone. Write down. Write down. I hope all of you written. So it is symmetrical ketone, unsymmetrical भी बनै परिबा. Suppose you are taking on heating, when calcium carbonate is released, it forms this. Note down. Over. Next is properties. So what are the chemical reactions given by the aldehyde and ketone? First, due to the presence of unsaturated bond. So which is unsaturated bond? Carbon oxygen double bond. Due to the presence of unsaturated bond, it can undergo addition reaction. Okay. So then the addition reaction जानचे, it can be nucleophilic addition, it can be electrophilic addition, it can be free radical addition. So in aldehyde and ketone, which type of addition reaction is taking place? Okay. In aldehyde and ketone, which type of addition reaction is taking place? Now it is nucleophilic addition reaction. It is nucleophilic addition reaction. Okay. Achha. So after nucleophilic addition reaction, how can I peribo? Now it can undergo condensation reaction. Then what else? It can undergo oxidation reaction. then reduction reaction माने ऐसो reaction aldehyde ketone discuss करिबा. Then disproportionation reaction. Okay, can you see? First nucleophilic addition reaction, then condensation reaction, then oxidation reaction, then reduction reaction, and disproportionation reaction. How can he period student? Yes, think. What else? The reaction can take place. एठी हमें polymerization reaction भी हुए aldehyde, but एठी हमें discuss करिवानी. So these are the major reactions which are taking place in aldehyde and ketone. Okay. So first, nucleophilic और physical properties देखि दबो. Physical properties similar हमें सब chapter सेमती discuss करिके आसुचे. So first, nucleophilic addition reaction. Before going to discuss the nucleophilic addition reaction, हमें कौन देखिबा ना reactivity of aldehyde and ketone. Reactivity of aldehyde and ketone. Okay. So among the reactivity, first is formaldehyde, then देखिबा, then other aldehydes, then ketone. So this is the order of reactivity. The most reactive among aldehyde and ketone is formaldehyde, then other aldehydes, then ketone. So how to decide the reactivity order? What are the points related to the reactivity order? Now there are two major factors. First is the steric factor. First is steric factor. Second is electronic factor. So steric factor and electronic factor कौन? Then in the structure you can see here around carbonyl carbon. Okay, around carbonyl carbon. So then reaction the reactive site is carbon and oxygen bond or carbonyl carbon. So it can be attacked by the nucleophile. So carbon center, जोटा carbonyl carbon है carbon center जितनी की sterically crowded थी वो, sterically crowded अच्छी. So it will be difficult for the nucleophile to attack to the carbonyl carbon. आउ जितनी की free थी वो carbonyl carbon जितनी की sterically less hindered थी वो तल से easily nucleophile तक attack कर परियो. बुझ पालो? ता माने जो दीटा ग्रुप की atom attach होइछंती, so तांको जदि bulkiness अधिक थिबो, बुझ पारछो? Bulkiness अधिक थिबो, so it will be difficult for the nucleophile to attack to the carbonyl carbon. ताले एठी कहा वो डिपेंड करला bulkiness और steric factor. So note down, more steric hindrance around carbonyl carbon, lesser is the reactivity. More the steric hindrance around carbonyl carbon, lesser is the reactivity. Student quickly note down. Make it fast. सो स्टेरिक फैक्टर बुझी पारलो सो आमे देखिबा सबुठारो लीस्ट स्टेरिक हिंड्रेंस कोठी अछि ना लीस्ट स्टेरिक हिंड्रेंस इज प्रेजेंट अराउंड द formaldehyde then other aldehydes then ketone जो अल्काइल ग्रुप अछि अल्काइल ग्रुप रे जदि कार्बन नंबर इंक्रीज हबो सो स्टेरिक हिंड्रेंस बढ़िबो यदि स्टेरिक हिंड्रेंस बढ़िबो यदि स्टेरिक हिंड्रेंस बढ़िबो त सेठी कोन हबो रिएक्टिविटी ऑर्डर will be lesser reactivity order will be lesser okay so yellow first steric factor then electronic factor so what about this electronic factor if we'll consider this so carbon center carries partial positive charge oxygen partial negative charge so हम कहि परिबा more partial positive charge around carbon more is the reactivity towards nucleophile yes or no more is the reactivity towards nucleophile ताले देखो ये जो partial positive charge अछि सुन बुझ परछो जो partial positive charge अछि so how the partial positive charge will be stabilized or diminished केमति हबो जदि ताकू ता सहित कि ओटे इलेक्ट्रॉन रिलीजिंग ग्रुप आटा जाई छथि आर यू गेटिंग इलेक्ट्रॉन रिलीजिंग ग्रुप का मैं अदर वे कोन कर परछे ना 2000 प्लस हाई ग्रुप so what is the nature of hydrogen hydrogen is zero inductive effect neither plus side nor minus side what about the nature of alkyl group that shows plus side effect so ta mane alkyl group jo present achi it shows plus side effect so plus side effect jodi alkyl group re rahila I hope all of you are getting my point jodi plus side group rahila alkyl group re plus side effect rahila alkyl group re ta mane kon hobo ko ta mane kon hobo na it can attack or it can release electron to the carbonyl carbon so carbonyl carbon को यदि electron release करिवो carbonyl carbon को यदि electron release करिवो ताले कोन हो को so जो कार्बन पाखरे partial positive charge से stabilize हे जिवो यदि कार्बन पाखरे partial positive charge slowly stabilize होबो so nucleophilic attack slow हे जिवो okay so rate of nucleophilic attack will be decreased ताले इलेक्ट्रॉनिक फैक्टर बुझ पारलो तो सो इलेक्ट्रॉनिक फैक्टर कोन ना मोर नंबर ऑफ alkyl groups around carbon more is the plus I effect and more is the stabilization of positive charge and hence lesser is the reactivity of carbonyl compound. Note down. Friend, quickly note down this. Okay, so complete a note karo. First steric factor, next is electronic factor. Steric factor, next is electronic factor. Any doubt up to this? If any doubt, you can write in the chat box. fine. So next is the examples of or types of nucleophilic.
बुझिएलानी
के स्टूडेंट को पॉइंट बुझेलानी को हम दीटा फैक्टर देखले. फर्स्ट इज स्टेरिक फैक्टर, सेकंड इज इलेक्ट्रॉनिक फैक्टर. ओके, सो कोटा बुझेला ना दीटा बुझेलानी
दीटा
ओके. चल देखो फर्स्ट है आम देखुचे हाउ रिएक्टिव द कार्बोनिल कार्बन इज टुवर्ड्स न्यूक्लियोफिलिक अटैक. तार माने न्यूक्लियोफाइल केते इजीली अटैक करछि. सो वेयर द न्यूक्लियोफाइल इज अटैकिंग टू द कार्बोनिल कार्बन, जो कार्बन अछि. सो कार्बन सेंटर को जेते इजीली न्यूक्लियोफाइल अटैक करिवो, सो दैट इज मोर रिएक्टिविटी ऑफ द कार्बोनिल कार्बन. जेते इजीली अटैक करिवो, सो इजीली अटैक करिया पे कोन हवा दरकार ना कार्बोनिल कार्बन फ्री हवा दरकार. और कार्बोनिल कार्बन पाखे दीटा जिंस, इट शुड बी स्टेरिकली लेस हिंडर्ड और क्राउडिंग अधिक न हवा दरकार. सेकंड है इट शुड हैव मोर पार्शियल पॉजिटिव चार्ज. कहीं न्यूक्लियोफाइल पाखे इधर नेगेटिव चार्ज रहइबो और नेगेटिव चार्ज सेंटर रहइबो. ताने न्यूक्लियोफाइल अटैक करिवो गोटे पॉजिटिव चार्ज सेंटर को. सो इलेक्ट्रोफाइल जोटा कहू इलेक्ट्रोफिलिक सेंटर कार्बन अच्छी, सो तापके जिते अधिक पार्शियल पॉजिटिव चार्ज रहइबो दैट विल बी इजीली अटैक्ड बाय द न्यूक्लियोफाइल. बुझा पड़ला. अच्छा, तो दीटा जिनस क्राउडिंग न हवा दरकार और लेस क्राउडिंग हवा दरकार. सेकंड इज पार्शियल पॉजिटिव चार्ज जदि अधिक रहइबो तार रेट ऑफ अटैक अधिक रहइबो. दीटा फैक्टर हला. सो फर्स्ट हम देखिबा around carbonyl carbon जदि में formaldehyde देखिबा टू हाइड्रोजन एटम्स आर देयर. अदर aldehyde गोटे हाइड्रोजन गोटे alkyl group and ketone two alkyl groups. So steric hindrance और क्राउडिंग जिते बल्की ग्रुप रहइबो सेते अधिक क्राउडिंग रहइबो. सो बल्की ग्रुप कोन ना जेंते alkyl groups आर बल्की ग्रुप्स and hydrogen is the least bulky group. ताले जदि दीटा हाइड्रोजन रहिला around carbonyl carbon, so that will be least bulkier, so more is the rate of attack. ओके, स्टेरिक हिंड्रेंस सेठी सबुठर कम रहइबो. तापर अदर aldehyde कारण गोटे हाइड्रोजन तो फिक्स हैला अदर aldehyde रे आ कीटोन रे दीटा alkyl ग्रुप रहिला हैला. सो ताले कीटोन रे भी जदी हम देखिबा टू मिथाइल ग्रुप अछि एंड टू इथाइल ग्रुप अछि, ताले बल्कीनेस कोठी अधिक हो, इथाइल ग्रुप रहिले बल्कीनेस अधिक हो. ताले सेठी रेट ऑफ अटैक कमी जाय. ताने मोर द बल्कीनेस ऑफ द alkyl ग्रुप lesser is the reactivity towards nucleophilic addition reaction. So steric factor बुझा पड़ला स्टूडेंट जे पचार थिलो स्टूडेंट रिप्लाई स्टेरिक फैक्टर बुझ पारलो ना नहीं. ओके, आई होप स्टेरिक फैक्टर बुझ पारलो. नेक्स्ट है इलेक्ट्रॉनिक फैक्टर. इलेक्ट्रॉनिक फैक्टर माने जिते पॉजिटिव चार्ज पार्शियल पॉजिटिव चार्ज रे अवेलेबिलिटी रहिबो अराउंड कार्बोनिल कार्बन, मोर इज द रिएक्टिविटी ऑर्डर. ताले पार्शियल पॉजिटिव चार्ज अवेलेबिलिटी कमिबो काहे कि ना जदि के इलेक्ट्रॉन रिलीजिंग ग्रुप अछि. सो इलेक्ट्रॉन रिलीजिंग ग्रुप माने हम त कहि परिबा प्लस साइड ग्रुप. इलेक्ट्रॉन रिलीजिंग ग्रुप माने हम त कहि परिबा प्लस साइड ग्रुप. बुझा पड़ला. सो मोर द नंबर ऑफ प्लस साइड ग्रुप अराउंड कार्बोनिल कार्बन, मोर इज द रिलीज ऑफ इलेक्ट्रॉन डेंसिटी टुवर्ड्स कार्बोनिल कार्बन. जदि कार्बोनिल कार्बन को इलेक्ट्रॉन डेंसिटी रिलीज हबो ताले कार्बोनिल कार्बन को जो पार्शियल पॉजिटिव चार्ज अछि से स्टेबलाइज हो जिवो. यदि कार्बोनिल कार्बन रो पार्शियल पॉजिटिव चार्ज स्टेबलाइज हबो ताले से केस रे कोन हबो को ना रिएक्टिविटी ऑर्डर स्लो हो जिवो, रेट ऑफ रिएक्शन कोन इज स्लो हो जिवो. ताले दीटा फैक्टर हला. सो फर्स्ट इज स्टेरिक, नेक्स्ट इज इलेक्ट्रॉनिक. ता माने मोर द नंबर ऑफ अल्काइल ग्रुप्स अराउंड कार्बोनिल कार्बन, मोर इज द stabilization of partial positive charge and hence lesser is the reactivity. So I think up to this clear. Next, types of nucleophilic addition reaction. So first, addition of HCN. Second, addition of sodium bisulfite. Addition of alcohol, then addition of NH3 or its derivatives. Okay. So before going to discuss these addition reactions, so what is the general mechanism of nucleophilic addition reaction? What is the general mechanism of nucleophilic addition reaction? Okay. So mechanism sabu addition reaction by applicable habo. So first step is formation of nucleophile. Okay, first step is formation of nucleophile. Second step is attack of nucleophile to carbonyl carbon to form intermediate. Then the last one is formation of product. Formation of product. So quickly note for this student. Quick 1 minute. Okay, note করছো? Okay, now addition of first example, addition of HCN. So the nucleophile kon hobo? The nucleophile is CN minus. So first step HCN in the presence of water that forms the nucleophile CN minus. Okay, that forms the nucleophile CN minus. So then the carbonyl carbon is attacked by the nucleophile CN minus. This next in third step H3O plus so this is cyanohydrin. This compound is known as cyanohydrin. So I go mechanism lecture, then we will explain. I'm going to aldehydes and ketones undergo addition of HCN to form the product cyanohydrin. To form the product cyanohydrin. Quick. So the mechanism of doubt student you can ask. Okay. Now, student, after this, when the cyanohydrin nature, if it undergoes hydrolysis, then the CN group will be hydrolyzed to give carboxylic acid. Okay. So if carboxylic acid is the functional group, then this position is alpha position. So हम कौन कोई परिवार को ना alpha hydroxy carboxylic acid. So the hydration of cyanohydrin gives alpha hydroxy carboxylic acid. Gives alpha hydroxy carboxylic acid. Okay. So note down, friend. Hydration of cyanohydrin gives alpha hydroxy carboxylic acid. Okay. So next is addition of sodium bisulfite. Addition of sodium bisulfite. So sodium bisulfite, then number which is the nucleophile here. Now that is HSO3 minus. So it attacks to the carbonyl carbon. It is O minus SO3H. Okay. O minus SO3H. Then after this, तापर हम कौन कहबा ना this one, the intermediate undergoes acid base reaction. अतः जानछो acid base reaction जोठी हबो, that is the equilibrium reaction. So why acid base reaction? Because sulfonic acid is stronger acid, whereas alcohol is weaker acid. हम जानछे from the conjugate acid base concept, stronger the acid, weaker is its conjugate base and vice versa. Stronger the acid, weaker is its conjugate base and vice versa. So the sulfonic acid stronger acid hela tale tar conjugate base weaker hobo, and alcohol jodi weaker acid hela tale conjugate base alcoholic side is stronger. So jodi conjugate base stronger hegala se H plus को pick करिवो आउ SO3 H जदि stronger acid hela se H plus को release करिवो. So next step is the acid base reaction, SO3 minus in the presence of Na plus, that is SO3Na. A step रे student को टिके बुझियो difficult हुए तो तब चाहिए को note कर परिवो. It is the concept of conjugate acid base. खाली एठी नुए हमर हालोफॉर्म रिएक्शन रे भी सेम कांसेप्ट अछि और कानिजेरो रिएक्शन रे भी सेम कांसेप्ट अछि. ओके. सो क्विकली नोट कर दियो. तापर जो नेक्स्ट रिएक्शन, that is addition of alcohol. I hope all of you are writing. Next, आपको कौन कहबा ना सोडियम बाइसल्फाइड प्रोडक्ट नेम इज सोडियम बाइसल्फाइड एडिशन प्रोडक्ट. Next is addition of alcohol. Next is addition of alcohol. So here aldehydes undergo addition with alcohol to form acetal through hemiacetal. ताମାନେ कौन? Suppose हम ले this -OH. So first this is hemi or O dash hemi. Then the hemisphere कौचे? So half sphere, similarly half acetal, hemiacetal. So further addition of one more alcohol molecule that gives acetal. That gives acetal. Note down. Then note down quickly. Now the question is, what about ketone? Can they undergo addition with alcohol? No. Kahinki? Na ketones are sterically more crowded. That is sterically more crowded achhanti, ताल से easily addition देवेन. कारण एट देखो यदि ketone मान 2 alkyl group अच्छी carbon से तो 2 alkoxy group मैंने बुझ परचो. So the carbon will be surrounded by 4 bulky groups, 2 alkyl and 2 alkoxy. ସେଥିପାଇଁ ସେ steric hindrance ଅଧିକ ଯୋଗୁ से तमर acetal formation करिवनी कि ketal formation करिवनी. But कौन हबो ना it can react with glycol to form cyclic ketal. ता माने हमें तो केमती लिखि परिबो ketone okay. So this one तो मन रखिया पई one second. हमें कौन कहले glycol. So CH2 so it कौन हबो so it is cyclic ketal. जैसे पचरा जो why the ketones cannot form acetal or ketal, acetal na ketal. Now it is due to the presence of a bulkiness around the carbonyl carbon. Okay, so note down. Over. Next, the last reaction under addition reaction, that is addition of NH3 or its derivative. So with the NH3 देखियो, here nitrogen contains lone pair, so it can act as nucleophile. Nitrogen contains lone pair, so it can act as nucleophile. If nucleophile hobo, tale it can easily attack to the carbonyl carbon. So suppose हम ketone नौचे, the product will be, finally the product will be this by removal of one water molecule. तो तब मन रखिया पाए हम एमती करि परिबा. Okay, so it is removal of one water molecule. Okay, so at the place of H, okay, at the place of this H, if you are taking any atom or group, if you are taking any atom or group, let's say Z, okay, let's say Z, if it is electron releasing, if it is electron releasing, then what will happen? If it is electron releasing, then it can easily increase the nucleophilicity around the nitrogen. Because student हम जानचे गोटे alpha effect हम पढ़ी under the concept that is nucleophilicity. So alpha effect कौन ना, if at the adjacent position of nucleophilic center, if at the adjacent position of the nucleophilic center any electron releasing group is present, okay, any electron releasing group is present, then it will increase the nucleophilicity of the nucleophilic center, alpha position or adjacent position. Similarly, यदि हम कौन कहबा ना any electron withdrawing group is present at the alpha position, यदि electron withdrawing group रहिबो ताल ता nucleophilicity कोन हिजो decrease हिजो, so its nucleophilicity will be decreased. Now I think you got the concept. So Z must be electron releasing. So S तो अच्छे, so Z जगह कौन है परिवो, alkyl group है परिवो, NH2 itself है परिवो, OH group है परिवो. So NCET गोटे table बने की देइछ. Okay, so just go through it. आउ ताको तुमको को reagent नले which type of products are formed, that you can also find. Hela. So this is all about the nucleophilic addition reaction. The student got data conversion lekho. So write down these reactions. Okay, write down the conversion reactions. Who students? Quick student. So I hope all of you are trying. Last 1 minute, then we'll discuss. Okay. Now, student, we are going to discuss this. First, in first question, there is increase of one carbon atom. So, gote carbon increase by mane pakao addition of cation. That are the best one. So, cation add kout hobo na cation add hobo in haloalkane. So, haloalkane that to find it kout achi terminal carbon re. Tale हमको terminal carbon रे halogen पाई only हमें HBr in the presence of H nu ही use करो. Alcoholic KOH, this, then addition of hydrogen bromide in the presence of H2O2. टिके lengthy step है ताकि मैं use करी परिबा dipole H. CHO. First question clear? Note कर दियो. तापर हम बाकी दिरा क्वेश्चन को जीवा. Completed? Second is, okay, it is simply reducing the carbon into half. So which method माने बखाओ half करे पे हम use करथिले, that is ozone lysis. ता माने ozone lysis कोठी हुए alkene रे. So हमको alkene को alkene रे convert करियार अछि. Again same, first हमें bromination apply करिबा. So that will give bromoalkane, then alcoholic KOH, this O3, zinc, water, CH3CHO. Second method clear? Third one, Again, third one is also reducing the carbon into half. तापे हमको again को मेथड यूज करिया पड़िबो ओजोन लाइसिस. This bromine H nu then alcoholic KOH then O3 zinc water ketone. Okay friends, with this the preparation of aldehyde and ketone, first preparation of aldehyde and ketone, then second one, what is the second method, second that we discussed, that is addition of or nucleophilic addition of aldehyde and ketone. So any difficulty student up to this? Any doubt? No. Okay. So just go through it. तापर हमें आगे किसी डिस्कस करिबा. Take 2 minutes, note down. Then we'll discuss nomenclature. Over. Now write some more question. These are also conversions. Quick. Take 2 minutes. I hope all of you are doing. In last 1 minute, तापर डिस्कस करियो. Okay, now first one carbon increase, then alpha hydroxy carboxylic acid. So टिके पुरान डिस्कस करते the best method is to hydrolyze the cyanohydrin. So first cyanohydrin बनेगा from this alkyne. तामाने alkyne को हमें कौन करीबा dilute H2SO4 in the presence of HgSO4. So enol बनेगा that tautomerizes to give ketone. Then HCN, so it gives cyanohydrin and hydration of cyanohydrin carboxylic acid. See, okay. So first, so alpha hydroxy carboxylic acid बने first हम mind रे immediately आसिया कथा कोना ना it should be the alpha hydroxy carboxylic acid means it should be the hydration of cyanohydrin. First over. Second is again increase in one carbon atom. So first bromine in the presence of H nu, then alcoholic KOH, then terminal position darkar achi H2O2 hydrogen bromide. Again Cassian, cyanide, hydration, CHO, hydration, CHO. I think it is over. Note color friend. Last one, this. So last one is, so हमें benzene को benzaldehyde बने परिया by using Gattermann OH reaction. Okay. Then this is metadieting. So concentrated HNO3 in the presence of H2SO4. So these are the reactions. Write down. Now, if you have written, then you can leave the class. We are going to wind up the class now. Thank you very much.